Welcome to AskPrep, your trusted companion for NEET and G preparation. Today we will study about a very important topic of physics, which is magnetism, magnetic field and Earth's magnetism. These concepts are fundamental to understanding various natural and technological phenomena, and they are crucial for students preparing for the NEET exam. So, let's dive right in. Magnetism is one of the essential forces in nature, and it is responsible for the behavior of magnetic materials and the generation of forces between objects. The force between two magnets or between a magnet and a moving charge is a direct result of the magnetic field. The magnetic field is an invisible force field that surrounds a magnet and exerts a force on other magnets or magnetic materials. This force field is the basis of how magnets interact with each other and with the world around them. When we talk about a magnetic field, we are referring to the area around a magnet where magnetic forces can be felt. The strength and direction of this magnetic field are represented by magnetic field lines. These lines represent the direction in which a north pole of a magnet would move if placed in the field. The denser the magnetic field lines, the stronger the magnetic field. Conversely, fewer lines indicate a weaker field. The direction of the magnetic field is always from the north pole of the magnet to the south pole outside the magnet. If the wire is coiled into a loop, the magnetic field inside the loop becomes stronger and more concentrated. If many loops are formed, as in a solenoid, the magnetic field inside the solenoid becomes uniform and resembles the magnetic field of a bar magnet. This concept is essential in the construction of electromagnets, which have a wide range of applications in industries and technology. Now, let's shift our focus to Earth's magnetic field. The Earth itself acts like a giant magnet, with a magnetic field that extends far into space. This field is important for a number of reasons, one of which is its role in navigation. Compasses rely on Earth's magnetic field to help us determine directions, with the needle aligning itself with the magnetic poles of the Earth. But how does Earth generate this magnetic field? The Earth's magnetic field is produced by the motion of molten iron and nickel in its outer core, a process known as the dynamo effect. This motion generates electric currents, which in turn produce the magnetic field. The Earth's magnetic field is not static, it changes over time. The magnetic poles themselves shift, and the strength of the magnetic field varies, which is why magnetic compasses must be calibrated regularly to remain accurate. Now, how do we determine the strength and direction of a magnetic field? The strength of the magnetic field is measured in Tesla, T, and it depends on how close you are to the magnet. The closer you are to the magnet, the stronger the field. The direction of the magnetic field at any point can be determined by placing a small compass there. The needle of the compass, which is a small magnet itself, aligns with the magnetic field at that point, showing us the direction. Magnetic fields are not only created by permanent magnets. They can also be produced by moving electric charges, such as when an electric current flows through a wire. A simple experiment to observe this is to place a wire with a current flowing through it near a compass. You will see that the compass needle moves, indicating the presence of a magnetic field. This magnetic field is circular around the wire. If you wrap the wire into a coil, creating a loop or solenoid, the magnetic field becomes much stronger and more concentrated inside the coil, much like a bar magnet. This is how electromagnets work. They are simply solenoids with a current running through them, and when they are wound tightly, they produce strong magnetic fields. Earth's magnetic field has several key features that are important to understand. First, there is the concept of the magnetic poles, the north and south magnetic poles of the Earth, which are not the same as the geographic poles. The magnetic poles are constantly moving, and they do not coincide with the geographic poles. This is why compass needles point towards the magnetic poles and not the geographic poles. Furthermore, the Earth's magnetic field is not perfectly horizontal. In fact, the magnetic field lines dip at an angle towards the Earth's surface, especially at higher latitudes. This is known as the angle of dip, and it varies depending on where you are on Earth. At the magnetic poles, the angle of dip is 90 degrees, meaning the magnetic field lines are pointing straight down into the Earth. At the equator, the magnetic field lines are horizontal, and the angle of dip is 0 degrees. Now, you might wonder how Earth's magnetic field affects us. Well, it plays a vital role in protecting the Earth from harmful cosmic radiation and solar winds, which are charged particles emitted by the Sun. The Earth's magnetosphere, which is created by the magnetic field, acts as a shield that deflects these charged particles, preventing them from reaching the surface of the Earth. Without this protective shield, life on Earth would be exposed to harmful radiation. Magnetism also has numerous applications in technology and daily life. From electric motors and generators to medical devices like MRI machines, magnets are essential in modern technology. For example, MRI, magnetic resonance imaging, machines use powerful magnetic fields to generate detailed images of the inside of the human body, enabling doctors to diagnose medical conditions without surgery. Another application is maglev trains, trains that use magnetic fields for propulsion. These trains float above the tracks, eliminating friction and allowing for faster, more efficient travel. Understanding magnetism is not only important for theoretical knowledge but also for practical applications in technology, medicine, and navigation. For NEET, you will need to have a solid grasp of the fundamental concepts like the magnetic field, Earth's magnetism, and the applications of magnets in daily life. This knowledge will help you solve problems related to magnetic fields and forces, which are common in the NEET exam. That wraps up our session on magnetism, magnetic field and Earth's magnetism. We hope you found this session helpful. Remember to keep practicing and revising these concepts as they form the core of many physics problems. Thank you. For more detailed and structured learning, make sure to subscribe to AskPrep for more sessions like this. Stay tuned, keep studying, and see you in the next video.